Welcome to this class, and today we'll be looking at likely post-UTME physics questions. And these questions were compiled from different universities. So let's dive right into it. First question here says, which of the following represent the correct precision for the length of a piece of wire that is measured with a meter rule? So when you measure the length of a piece of wire using a meter rule, they ask you, what is the degree of accuracy of your meter rule? That's what the question is simply saying, the degree of accuracy of the meter rule. Now, your meter rule can measure the length of any object up to the degree of 1 millimeters or 0.1 centimeters. But also note that values of measurement are always to 1 decimal place. So it must always be to 1 decimal place. So looking at the options here, option A says 35 millimeters. 35 millimeters would have been correct, but it does not have a decimal place. Then we have 35.0 millimeters, we have 35.00 millimeters, 35.1 millimeters. So your meter rule cannot measure 35.1 millimeters. Your meter rule also cannot measure 35.00 because that is what? To the hundredths of a millimeter. And your meter rule cannot measure that. So the correct answer to this question is option B, which is 35.0 millimeters. Moving on to the next question. Question number 2 says, to keep a vehicle moving at a constant speed V requires power P from the engine. The force provided by the engine is dash. So they are asking you to what? To derive a formula that has to do with what? Force, but it should constitute the speed and the power. So we know that force on its own, or let's just say that power is supposed to be equal to work done over time. And we know also that this is the same as saying that power is equal to force times distance over time, which can also mean that I have my power to be equal to force times distance over time. And we know that distance over time is equivalent to saying velocity, which means that my power is equal to force times velocity. And this can also mean that my force is equal to power over velocity. So the relationship here that connects what? Force, power, and velocity is simply saying that what? Force is equal to power over velocity, which is what? Option A. So the correct answer is option A. Moving on to the next question, question number 3. It says, which of the following statements gives the true difference between evaporation and boiling? Which of the statements gives the true difference between what? Evaporation and boiling? Remember, figure 1 says, evaporation occurs at all temperatures, while boiling occurs at a fixed temperature for a given pressure. Remember, figure 2 says, evaporation is a surface phenomenon, while boiling is an interior phenomenon. Remember, figure 3 says, evaporation is affected by surface area, while boiling is not. So, looking at all of these, you can tell that Roman figure 1 is absolutely correct. Roman figure 2 is partially correct, saying that what? Evaporation is a surface phenomenon, but boiling is not an interior phenomenon. And Roman figure 3 is also what? Absolutely correct. So if we're looking at our options, we're going to be looking at options that have to do with what? Roman figure 1 and Roman figure 3. So the correct answer is option B, which is Roman figure 1 and Roman figure 3. So that takes us to the next question, which says, equal masses of copper and rubber are raised to the same temperature. After some time, the copper was observed to be at a lower temperature because option A says the specific capacity of copper is lower than that of rubber. Remember, figure 2 says, option B says copper expands more than rubber. Option C says the specific capacity of rubber is lower than that of copper. Option D says rubber expands more than copper. Now, when you heat up a substance, the substance increases based on the specific capacity. So substances that have lower specific capacity will easily be heated up and they will easily lose their heat compared to substance with higher specific capacity. So a substance with higher specific heat capacity will retain more of its heat than a substance with lower specific heat capacity. So looking at this, it means that what my copper has lower specific capacity, hence it is losing heat faster than that of the rubber. So the correct answer is that the specific capacity of copper is lower than that of rubber, which is option A. So that takes us to question number 5. We say, which of the following statement is correct about a long-sighted boy who does not put on glasses? Option A says he cannot see distant objects clearly. Option B says the rays of light from a close object are focused in front of the retina. Option C says his eyeball is too long. Option D says parallel rays of light are focused behind the retina. Now, when you say a person is long-sighted, it means that that person can see objects that are very far, but the person cannot see objects that are very close by. So the person can see far objects, but not objects that are close by. So objects that are close by are blurry, but objects that are far off can easily be seen by this person because the person is what? Long-sighted. And when that happens, you discover that what? The parallel rays of light are focused behind the retina. Hence, close by object cannot be seen. So this person cannot see because parallel rays of light are focused behind the retina. That is what happens to a boy that is not what? Using glasses, although he has what? Long sight. So the correct answer is option D. So that takes us to question number 6, which says, a 12-volt battery has an internal resistance of 0.5 ohms. So we have the EMF of this battery as 12 volts and the internal resistance as 0.5 ohms. If a cable of 1 ohms resistance, so we have the external resistance to be 1 ohm, is connected across the terminals of the battery, the current drawn from the battery is that. So we are looking for the current we do not know. And we know that the EMF of a cell is equals to I open bracket arrow plus arrow. So this means that my current is simply saying that I have what? EMF over arrow plus arrow. So this means that the current in this battery or drawn from the battery is equal to 12 divided by 1 plus 0.5, and that will give me 12 divided by 1.5. So if I divide this, 12 divided by 1.5 should give you 8. So that will give me 8 ampere. So the correct answer to this question is option B, which says what? 8 ampere. Moving on to question number 7. It says, if two parallel wires carry current flowing in the same direction, the conductors will dash. So when two parallel wires carry current flowing in the same direction, they attract themselves. So when the wires are parallel and they are carrying this current flowing in the same direction, they attract themselves. But when they carry current flowing in opposite direction, they repel themselves. So the correct answer to this question is option A, which says that they will attract each other. They attract each other. So that takes us to question number 8, which says, from the generating station to each substation, power is transmitted at a very high voltage so as to reduce dash. So they are saying that whenever you are trying to transmit power from one point, which is the station to the substation to the smaller stations, they always increase the voltage. Why do they increase the voltage? The voltage is increased so as to reduce the heating in the coils, so that the coils will not be heated up. Because if the voltage were lower and the current is higher, then the coils will be heated up. But the voltage is higher, thereby reducing the current, and thereby the amount of heat that is generated within the coils will be reduced. So the correct answer to this question is to reduce the heating in the coils. So the correct answer is option C. So that takes us to question number 9, which says, two turning forks of frequency 256 Hz. So we have the first frequency F1 to be 256 Hz and 260 Hz. So we have the second frequency to be 260 Hz. are sounded close to each other, what is the frequency of the beats produced? So you are sounding these tuning forks close to each other. So we're trying to find the frequency of the beat that we produce. Now remember that these tuning forks are sounded together. Since they are sounded close to each other, it means we're going to be adding their frequencies together to get the frequency of the beats, which means what I'll be having, the frequency of the beat will be F1 plus F2. At the end of the day, that will give me 256 plus 260. And that should give me 516. So I have 516 Hz. It means that the frequency of the beat produced will be 516 Hz, 516 Hz, which is option A. So that takes us to question number 10, which says the fundamental frequency of vibration of a sonometer wire may be halved by. Now there's a relationship between the fundamental frequency of a sonometer wire and the length of the sonometer wire. So the fundamental frequency is directly related to, is having an inverse relationship with the sonometer wire. So my fundamental frequency F0 is inversely related to the length of the sonometer wire. So if there's an increase in the sonometer frequency, the fundamental frequency, there will be a decrease in the length of the wire. So when you have the frequency, the fundamental frequency, then automatically it means that the length is going to be what? Double. So long as you have the frequency, the length will be double. If you have the length, the frequency will be double. So they are working in what? Inverse relationship. So an increase in one leads to a decrease in the other. So if the frequency of vibration of the sonometer wire is to be halved, then there will be what? A doubling of the length of the wire. So the correct answer is option A. The length of the wire will have to what? Double once you have the fundamental frequency. So that is also question number 11. It says a transformer has a primary coil with 500 turns and a secondary coil with 2,500 turns. So we have our primary turn as 500 and we have the secondary as 2,500. Then it said when the voltage input to the primary is 120 volts, so we have the VP as 120 volts. The question is the output is what? So we are looking for the VS. We do not know. And we know that NS over NP is equals to VS over VP. So if you apply this formula, what I'll be having here is simply saying that I have 2,500 over 500 is equal to VS over 120. So if we simplify this further, I'll be having 5 over 1 is equals to VS over 120. If I cross multiply, it means my VS is equals to 5 times 120. And that will give me 600 volts. So it means that the output voltage or the voltage in the secondary coil is going to be 600 volts, which is option B. So that takes us to question number 12, which says the principle of operation of an induction coil is based on that. So they're asking what law is the principle of operation of an induction coil based on? This principle is based on Faraday's law. The principle of an induction coil is based on Faraday's law, which is option C. So that takes us to question number 13, which says 4 grams of radioactive material of half-life 10 days. So the initial mass is 4 grams and the half-life is 10 days. Is speed on a laboratory floor. How long will it take to disintegrate 3.5 grams of the material? So we are looking for the time, we do not know. and disintegrates 3.5 grams of the material. So the number that will be left will be equal to 4 minus 3.5, and that will give me 0.5 grams. So we know that the mass that is left is equals to the original mass times 1 over 2 raised to the power t over t half. So this is the same thing as saying that I have 0.5 is equal to 4 times 1 over 2 raised to the power t over 10. So this will give me 1 over 2 divided by 4 is equal to, this is 4 times 1 over 2 raised to the power t over t half, which is 10 now. So divided by 4. So this 4 cancel out this 4, and I'll have 1 over 2 times 1 over 4 is equal to 1 over 2 raised to the power t over 10. So this will give me 1 over 8 is equal to 1 over 2 raised to the power t over 10. So this is the same as saying I have 1 over 2 raised to the power 3, because 1 over 8 here is 1 over 2 raised to the power 3. This is equals to 1 over 2 raised to the power t over 10. So 1 over 2 cancel out 1 over 2. It means I have 3 is equals to t over 10. This means that my t is equals to 30 days. So it means that the time it will take for this particular radioactive material to disintegrate 3.5 grams and leave only 0.5 grams of the material left, and leave only 0.5 grams of the material, is going to be what? 30 days, which is what? Option C. So that takes us to question number 14. We say, which of the following statements correctly describe cathode rays? Which of the following statements correctly describe cathode rays? Remember, figure 1 says they consist of tiny particles carrying negative electric charges. Remember, figure 2 says they are deflected in a magnetic field but not in neutrons, and are deflected in an electric field. Remember, figure 3 says they consist of fast-moving neutrons and are deflected in an electric field. Now, we know that the cathode rays, they consist of tiny particles carrying negative electric charges, and they are not what? Consisting of neutrons, and they are not neutrons, but they are what? Deflected in electric field, and also what? Deflected in magnetic field. So the correct answer to this question is option C, which talks about what? Roman figure 1 and Roman figure 2 only. So Roman figure 1 and Roman figure 2 are correct about cathode rays, which is option C. So that takes us to question number 15, which says, which of the following is most strongly deflected by a magnetic field? Now, the particle that is most strongly deflected in a magnetic field is the negatively charged particle. And in this case, the negatively charged particle is the beta particle. So the beta particles are the most deflected in a magnetic field. So the correct answer is option C. So question number 16, it says, which of the following is a set of vectors? Which of the following is a set of vectors? Now, remember we said something earlier about vectors in a previous video, where we said that what a vector is a quantity that has what both magnitude and direction. So they are asking us, which set of quantities here contain only vectors? So option A says force, mass, and momentum. Force and momentum are vectors, but mass is a scalar quantity. Option B says acceleration, velocity, and momentum. Option C says mass, weight, and density. Option D says mass, volume, and density. Without much calculation here, just because I've talked about mass earlier and I said that mass is a scalar quantity, looking at the other two options that contain mass, we know that those other two options will also be wrong because they contain the same mass that I said was wrong earlier in option A. So the correct answer is option B, that talks about what? Acceleration, velocity, and momentum. Acceleration is a vector, velocity is a vector, and momentum is a vector. So that makes option B to be correct. Now, if you have been enjoying this video down to this moment, please subscribe and go to our channel for more videos just like this. Okay, that takes us to question number 17, which says a catapult used to hold a stone of mass 500 grams. So we have a catapult that is used to hold a stone of mass 500 grams. So the mass of the stone was given in the question as 500 grams, which is equivalent to saying 0.5 kilogram or 1/2 kilograms. Extended is extended by 200 centimeters. So the extension x is 200 centimeters, which is equivalent to 2 meters. With an applied force F, if the stone leaves with a velocity, so we have a velocity of 40 meters per second. The value of F is dash, so we don't know F. Now, in this question, all you have to do is what? Bring a relationship that has to do with this. Now, we know that the work done in an elastic material, is equal to half Fx. But we also know that work done, since this particular stone moves a particular distance, it will be having what we call kinetic energy. And our Ke, which is also equal to work done, is half mv squared. So if I equate both equations, since work done is also equal to kinetic energy, we know that work done is also equal to kinetic energy, or energy generally. So this is the same as saying that I have half Fe or Fx is equals to half mv squared. So half can cancel out half, it means I have Fx is equals to mv squared. So with this, I can now solve for the value of the force that was applied. Looking at this, the force that was applied is Tf times the extension there is 2. This is equals to the mass is 1/2 times the velocity that was given is 40, and then it is squared. So I have 2F is equal to 1/2 times 1,600. So 2 here, 1, 2 into this, I have 800. It means I have 2F is equals to 800. Divide both sides by 2, divided by 2. It means that the force is equals to 400 Newton. So this is equivalent to saying that the force is equals to 4 times 10 raised to 2 Newton. So the correct answer to this question is 4 times 10 raised to 2 Newton, not Newton per meter squared. 4 times 10 raised to 2 Newton, which is option A. That is also question number 18, which says an electric heater is used to melt a block of ice 1.5 kg. So the mass of the block of ice is 1.5 kilograms. If the heater is powered by a 12-volt battery, the voltage is 12 volts. And a current of 20 ampere flows through the coil. So we have a current of 20 ampere flowing through the coil. Calculate the time taken to melt the block of ice at 0 degrees Celsius. So the time taken is unknown. And we're given the specific latent heat of fusion of ice as 336 times 10 raised to power 3 joules per kilogram. So we know that the quantity of heat that was used by the heater is equivalent to the work done, which is IVT. And we know that the quantity of heat is also equals to the latent heat of fusion of ice. So this means that my IVT is equals to ml. If I impute my values, this means I have 20 times 12 times T is equals to 1.5 times 336,000. So this means I have 240T is equals to 336,000 times 1.5. So that will give me 504,000. So I divide both sides by 240 divided by 240. So it means that my time here is going to be 2,100 seconds. Now, If you discover all our options are in minutes, so I will convert this to be in minutes, which means that what I'll be having is 2,100 divided by 60. So I'll divide this by 60, and that will give me 35 minutes. So the correct answer to this question is option B, which is what? 35 minutes. So that is to question number 19, which says 200 grams of water at 90 degrees Celsius is mixed. So we have a mass of 200 grams, which is equivalent to saying I have 200 over 1,000. That will give me 0.2 kilograms. At a temperature, θ1 here is 90 degrees Celsius. Is mixed with the same quantity of water. So I have my new water, the same quantity, which is also 0.2 kilograms. At 30 degrees Celsius, the temperature of this water is 30 degrees Celsius. What is the final temperature? So we are looking for θ final, we do not know. But we know that heat lost by the hot water must be equal to the heat gained by the cold water. So this means I have MC change in theta is equals to MC change in theta. Now our C will not be needed because we're talking about water, so C will cancel out C. So this means I have M1 in brackets θ1 minus θ3, which is final temperature here, is equal to M2 in brackets θ3 minus θ2. Why is there difference in the change of temperature here? On the heat loss side, the temperature of the substance losing heat is always higher than the final temperature, which means my θ1 will always be higher than my θ3. That's why I'm having θ1 minus θ3 on the heat loss side. And on the heat gain side, the final temperature is always higher than the temperature of the substance gaining heat, which is why I'm having θ3 minus θ2. So with that, I will solve the questions and get the value of my θ3. So my mass here is 0.2 in brackets. θ1 there is going to be 90 minus θ3 is equal to 0.2 in brackets θ3 minus 30. Now 0.2 is on both sides, so they can cancel out themselves. So I have 90 minus θ3 is equals to θ3 minus 30. So if I collect like terms, I'll be having 90 plus 30 is equals to θ3 plus θ3. So this will give me 120 is equals to 2 θ3. Divide both sides by 2, divided by 2, it means my θ3 is equals to 60 degrees Celsius. It means that the final temperature of the mixture is 60 degrees Celsius, which is option C. So this is a typographical error. This is not 600 Celsius, it's 60 degrees Celsius. So that is the question number 20, which says, for a short-sighted person, light rays from a point on a very distant object is focused dash. So when a person is short-sighted, it means that the person can see close object, but the person cannot see far-off object. So if light from a distant object is incidented on the eye, the image that will be created will be placed in front of the retina. So it will not get to the retina, hence the person cannot see it. So the correct answer to this question is that the object will be focused, or the rays of light will be focused in front of the retina, which is option A. So that takes us to question number 21, which says dispersion of light by a glass prism is due to the dash. So dispersion of light is when white light passes through a glass prism, for example, a triangular prism, and there is what? Separation of the light into different colors. So we call that principle dispersion of light. And this is due to the speed of the different colors of light. So the different colors of light have different speed. So as they pass through the prism, they are what? They are separated into their separate colors based on their speed. So we call it what? Diffraction of light. So it is due to option A says the different hidden colors of the glass Option B says the different speed of the various colors in the glass. Option C says the defect in the glass. And option D says the high density in the glass. So the correct answer is the different speed of various colors in the glass. So the different colors have what? Different speed. So which is option B. So that takes us to question number 22. Which says to convert an AC dynamo to a DC dynamo, the dash. Option A says the number of turns of the coil is increased. Option B says slip rings are replaced with slit rings. Commutator. Option C says the number of turns of the coil is reduced. Option D says split rings commutator is replaced with slip rings. Now, slip rings are present in AC. Slip rings are present in AC dynamo or AC generator. Dynamo is a generator. So in AC generator, what you have there is slip rings. You know what? Converting. So, but when you now replace your slip rings with a slit ring is only present in a DC, a direct current dynamo or a direct current generator. So when you replace your slip rings, which are present in AC, with slit rings, it means you have converted your AC generator to a DC generator. So the correct answer to this question is option B, which says what slip rings are replaced with slit ring commutator. So that takes us to the next question, which is question number 23. It says, in an AC circuit that contains only a capacitor, the voltage dash. So in an AC circuit that contains only a capacitor or an AC circuit that contains only an inductor, if it contains only an inductor, it means that the voltage will be leading the current by 90 degrees. But if it contains only a capacitor, it means that the current will be leading the voltage by 90 degrees. If it contains only inductor, the voltage will be leading by 90 degrees. If it contains only a capacitor, the current will be leading by 90 degrees. So let's look at our options. So it says the voltage, option A says, will lag behind the current by 90 degrees. Option B says the voltage will lead the current by 90 degrees. Option C says the voltage will lag behind the current by 180 degrees. Option D says the voltage will lead the current by 180 degrees. Now, based on the explanation I gave earlier, you know that what option B, C, and D are incorrect. Option B here is talking about what? That of what? An inductor. So the correct answer is that the voltage will lag behind the current by 90 degrees, since the current will be leading by 90 degrees. So the correct answer is option A. So that takes us to question number 24. Which says, the purpose of dielectric material in a parallel plate capacitor is to dash. So why do we put a dielectric material between the plates of a capacitor? Now, we put those dielectric material between the plates so as to increase the capacitance of the capacitor. And it is based on the type of dielectric material. So the type of dielectric material will determine by how much, what portion are we going to be increasing our capacitor by. So the dielectric material determines the proportion by which we are increasing the capacitance of our capacitor. So the reason why we put a dielectric material is not to make it an insulator, but instead to increase the capacitance of the capacitor. So the correct answer is to increase, it increases the capacitance of the capacitor, which is option A. So that answers the question number 25. If light with photon energy 2 eV, so we have light with photon energy 2 eV, is incident on the surface of metal with work function, so the work function is 3 eV. Then, now, when we talked about the photoelectric effects in a previous video that we did, I told you that for electrons to be emitted from a metal when photons are heated on it, or when photons hit it, or when light hits the metal, then the photon energy of those photons that hit the metal must be higher than the work function, or must be equal to the work function. But if you look here, our photon energy is 2 eV and our work function is 3 eV. It means that when this photon hits this particular metal, no electron will be emitted, as the what? The photon energy is not up to the work energy, so no electrons will be emitted from that particular metal. So the correct answer is saying that no electron will be emitted, which is what? Option A. So we've come to the end of today's class, and I believe that you had a wonderful time. Don't forget to go to our channel for more videos that we've done previously, both on topical and questions just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 type of different exams, including JAMB, WAEC, Kakao,